So, welcome to our webinar, our fourth webinar this time. My name is Friedemann Stang, and I'm here today with my two colleagues, Joe Herich and Pina Magino. If you have any questions of any kind, you can always just write in the chat. I think most of you might already know that. Don't hold back. Whatever question you have, no one else can see those questions, so feel free to ask away. Today, we're going to talk about the new features for removables, meaning different types of new features for full dentures, single arch or both arches, and also for partial frameworks. We're not going too much into detail for both of those modules because obviously we want to talk about all of the new features. We might talk about things that have been integrated a long time ago as well, but please keep in mind we only have 1 hour, so we try to keep it concise. So as always, we first have to start with our copyright notice. Any redistribution or reproduction, distribution, or passing on in whole or part of this broadcast in any form to any other party at any time without the prior written consent of exocad is strictly prohibited. As a reminder, we will upload the recordings of those webinars later on our YouTube channel or on our homepage, so you might be able to watch them later on. Please don't redistribute them yourselves. So for today's topic, we are first going to talk about the full dentures. So we have new preset features, for instance, where you can load presets for teeth and so on. The new library manager, we're quickly going through the workflow for a single arch denture as well to see what's new there. And then we're going to look into the PartialCAD Galway release. So here it still says it's a sneak preview, but we already released the new version. I think at the end of last week, the new version of the PartialCAD is now available, the Galway release, so we can look at the new features, what's going on there. As always, here's a list of our of resources that you can use to learn more about exocad software in general. Obviously, our wiki. Most of you might already know, you can just go to wiki.exocad.com, but you can alternatively just click on those little question marks in our software and it opens up a wiki page related to the tool that you're in the software right now. You can go to our YouTube channel, which is just exocad on YouTube, or videos.exocad.com, where you can see lots and lots of different tutorials for tools and marketing videos, and also all the webinars, all the presentations that we had to see all about the different topics. And then on Facebook, you can go to our Facebook page where you will find all of the most recent news and so on. But also you can go to the exocad experts Facebook group, which is independent from us, has 30,000 members at the moment, I think. And since it's independent, people are talking a lot more open about the software. Many of us are also members of the group, so there's often also a post from us about different topics there. And one of the most, maybe not important, but interesting things is our newsletter, where you can get news about new releases, for instance, the new Galway release, if you haven't heard in any other way already, or about events that we're holding and so on, like those webinars here. Okay, I don't think I forgot anything, so we can go right on with the software itself. Today we're starting with the full denture module. First, I'm going to show you the tooth presets, the setups that you can use for the full dentures, and afterwards we're going over a single arch denture. Just as a short explanation here for the full dentures, we set up the work type full denture for both jaws. In this case, we have a mill base and teeth material selected and the bite rim scan. It doesn't really matter for this example here, but just if you have never seen the full denture module, this might be a bit confusing. So for full dentures, you're not selecting the material directly, you're selecting the workflow. So how are you going to produce your full denture in the end? Because for a full denture, obviously you're going to use a type of acrylics, but the big difference here might be if you are going to mill or print the base, or if you're using stock teeth, or if you're going to produce the teeth yourself, and even then, are you going to print or mill those teeth? And for the stock teeth, there's also differences if you're able to rework the shape of those stock teeth later on in the machine, or if you have to use the original shape of the stock teeth. So there's lots of differences here in the production method. Normally in your lab, you will use one of those methods and stick to it. But maybe you can use several different ones. It's based on your preference. So here in this case, I'm just going straight to the design. One important thing is I'm going to load a scene file where we already went through the model analysis, so I can just show you the new features about the tooth libraries and the setups, and we don't have to go through all of those workflow points again, so you don't have to see the same thing over and over. Okay, here we are in a step which is just the denture tooth placement. So directly after the initial model analysis, as you can see, there's an initial setup with generic denture teeth here. What I want to show you now is here the new tab presets. You can see that's the normal selection here for all of the different libraries, but we also now have the presets here. A short reminder, because we introduced the library manager in the Galway version. So if you have seen our last webinars, you already know that you can download, for instance, implant libraries directly from the software now. You can do the same for your FullDenture tooth libraries. So if you go into your tooth library selection, you have up here your download more libraries button. In the past, this took it to our homepage, but now if you click on it, it starts the library manager, and you can select the tooth libraries that you want to download directly from here. And you see there's all of those to select from. I normally recommend only downloading the ones that you actually want to use. So the list is a bit shorter and it's easier to find the ones that you want to use in the end. And just select those and add to the download list, enter your details. I'm not going to demonstrate that again, but as you see, you can also do it for your FullDenture libraries. So the new tab for the presets, on the other hand, you see it looks a little bit different. There's a library filter for only scalable and non-scalable teeth. In case for your production method, it might be important if the teeth are scalable or not. If you're going to print or mill the teeth yourself, obviously you can scale them. But if you're using stock teeth, scaling them to have the shape bigger than the original shape doesn't make any sense. So here you have a drop-down menu, and you see there's a small selection here. It's all generics. We entered just presets for our generic libraries, but just as you can see, it tells you here what type of posteriors and anteriors are used and the bow width difference. As a reminder, the bow width is based on your model analysis. The software kind of measures the distance between the canines and then also the distance between the canines and the molars, and kind of selects a tooth library or gives you an information about the tooth library based on the length of this bow. So you see if the teeth are too big or too small for the whole jaw. And this is the number back here showing you, okay, this bow would be 4.8 millimeters too small for this whole jaw. And if I select something here, see something that's not that far off, you see the whole setup just changed. It just it's kind of the same library. It's still generic teeth, but you can use whatever tooth libraries you want. So if I select a preset, it loads automatically the library here and the setup that was set up in the past and saved here. You can also select here if you want to place a second molar or not, and you can actually scale your optionally scalable teeth or not. And you also have an auto select where the software, based on the size of the tooth bow, selects the one that fits the most. So just for the demonstration purposes, because obviously, okay, we're using presets for our generic teeth here. In your lab, realistically, you're maybe not going to use the generic exocad teeth, but maybe some kind of other tooth library. So I'm going to select whatever. I'm just going to scroll up and see, okay, it's in this case, Candulor is right here. I'm just going to select whatever size that nearly fits and going to set them up. Might not fit perfectly. I just selected something randomly. So it's easy to see if this is a setup that I made or if it's just a generic setup. And then I'm going to the next step. And now I can obviously change the setup as always. And I'm going to create something here that we can immediately recognize, maybe something that's super weird where something is a little bit off, let's just like this, maybe not that extreme, but you see, okay, this is not a normal setup. This is something we created. And then you can just switch to the expert mode. Obviously, the software checks if there's any problems and so on, but it doesn't matter at the moment. And on right click now, you see you have here export current tooth setup as preset. You can just click this and I can, oh, that's fine. Okay, I can just call it whatever. Just call it webinar. So immediately can recognize it. Then it's going to save some XML files that I can also name specifically. So the setup and the file that it's saved in can have different names, so it's easier to recognize them. And now I'm just going to go back to our wizard, back to the step for the tooth selection. And here in presets, obviously I have to select all. Here's the webinar one. If you're wondering why I have to select all, I just selected teeth that are not scalable. And if I select here as a filter only scalable, then they're not visible. But if I say all or non-scalable, then they're also available. And if I click on that, you will see it directly loads the weird setup that I just created. So you can create your own tooth setups. You can create them as perfect as you want with different like occlusion types and so on, different combinations of libraries, different sizes, different whatever you want, obviously, and can save them yourself. The providers of the libraries can also create their own and provide you with those setups. So it's a super simple system, as you can see. It's a matter of seconds of saving and loading those. So this is obviously a very nice thing for full dentures because you get really quick in setting up your full dentures that way, because sometimes you just want the perfect setup and that's it. But for now, I'm going to close the case again. And we're switching to the single arch dentures. So here for the single arch dentures, also can see we selected here print base and teeth. That means both the base and the teeth are going to be printed. That means we can actually scale our tooth shapes. If we use stock teeth, they're scalable, so we can select whatever size we want. Also interesting is that we can actually select connectors here for our tooth arch, meaning that in the end we get one piece of a tooth arch where all of the teeth are connected, that we can print as one piece and just stick into the base and glue them together with the fitting acrylics that work with the material that I used to print it, and I'm done. If I would print all of the teeth individually, which also works, maybe I could use a nice layering, but then I would have to set up all the teeth individually, would be a little bit more work. So it's a pro and con for everything. Here for this case, I'm also loading a scene file after the model analysis, so we don't have to go through that process. There was no changes in Galway in that regard. And you see there's an initial tooth setup already. We selected here generic teeth. And you see we start here in the correct denture tooth placement step already. So the setup was done. We can now correct the positions. As you see, we have the chain mode or the simple mode available for the full denture teeth. Just going to hide the analysis here. And you see we can, as always, change the whole setup however we want and so on. But I'm just going to leave it as the original that we have saved in the scene, because obviously for the setup, there's also no real changes. And now we can freeform everything. Since we selected scalable teeth, I can freeform the teeth however I want. I mean, if I'm going to print the teeth myself, the shape doesn't really matter for the software. As you see, we changed the generic tooth library a little bit. So here the base is shorter. This is only for the full denture tooth libraries. You might have seen in the selection, we also have now very many different sizes of generic teeth available for the dentures, since they are based on like stock teeth. So for the examples, it makes perfect sense to have different sizes here. And also for the full dentures here, the bases are shorter. So if you produce this to be printable or millable and to be placed in a gingiva base, there's enough space here to place them and you don't have to trim them every time. So here for the freeforming, as you see, we have very strong contact points. I can also show the distances here. And we have intersections with everything. And I can obviously adapt the teeth. This is also based on your production method. If you're, again, going to print or mill your teeth, then you can reform them however you want. If you're going to use stock teeth, you might have, based on your production method, to manually reduce those, or maybe you have a production method where you can actually trim your stock teeth as well. And as you might see, there's the dynamic selection for single arch dentures. We obviously can also use an articulator. So calculating, then we can select our denture base. We changed some parameters here. I'm going to change the insertion axis a little bit. We changed the parameters here. Specifically, you can see we still have a very small offset between the gingiva and the acrylics, makes sense. But we changed the angle and the allow undercuts here for the default values. So you can have undercuts in your denture base. Obviously, the angle of minus 30 degrees means that if there is an undercut, you can actually go for 30 degrees under those undercuts. And the same is here, it's allowed for 1 millimeter. For dentures, you often want undercuts to not be blocked out. And you can see here where there actually was some block out, maybe a little bit, maybe 1 millimeter is already enough. You can also go to the freeforming here for your dentures. Obviously, you can just remove or add block out material here. But one thing I really like is you don't only here have the brush, you also have here the offset to scan data with brush, which is the normal freeforming with brushes, like the freeforming you know, but the offset to scan data with brushes, you can actually use a brush to paint an area on your gingiva. Maybe try it a little bit nicer. And then you can add like a small spacer, an offset here. It's 0.2 millimeter, which I can just apply. And this is, in this case, obviously like a tinfoil that I can actually add to have a little bit more spacer over my papilla. And a nice thing, I mean, all of you who use tinfoil for the full dentures know the process. You stick it on your model, then you press your denture in acrylics, and then you remove the tinfoil again. And you always have this hard edge here that you have to smoothen up a little bit. But here in this case, we can actually smoothen this before even producing the full denture. So you can see, I can just go here and smooth the edge. The spacer is still applied, but the edge here is something that you don't have to think about anymore. It's pretty nice, I think. So I'm just going to the next step. Then we can create the top of the denture base. You see here in the design denture base, we have the properties, which are the values of your denture base, like the thickness and so on. We have the correct draw tab, so I can start drawing the whole margin line for my base. But I also have here the detect tab. This is something that's a little bit weird. Sometimes you see those small arrows here where you can switch between the tabs if you have too many tabs for your screen resolution, for instance. And in some languages, it might happen that the detect tab is kind of pushed to the right-hand side and you cannot see it, but you can still use those arrows to find it. And with that, I just have to click on at least 4 points to find, to automatically detect the margin line. I say at least 4 points because the software just finds the hardest edge here. Here it, as you can see, sometimes goes on the outside. If you have a lower jaw, for instance, I prefer drawing it right away because obviously the shape of a lower jaw is a little bit more complicated in that regard. And here you see the margin line is completely detected. I can switch back to the properties if I want to and maybe change some of those values, or I can just click on apply. I could also just click next to start the calculation right now, and the software starts creating my denture base. Is there any questions already while we're waiting for the calculation?
Well, so far we only have a question about the articulation, but we will handle that. And besides that, one question was will instant anatomic morphing be available for scalable teeth?
It is not yet available for scalable teeth because instant anatomic morphing is also not available for like virtual articulators and so on. But I presume it will be available for all kinds of teeth that can be reformed in the work process. Yes, I don't see a reason why we wouldn't make it available in the future. Okay, then I'm going next. And now you see there's a step for the connector, since I mean all of the teeth can be connected, and you might see that there is down here for your connectors, you have the advanced placement options. We talked about connectors, I think, in the first webinar for these sessions like 3 weeks ago, when we talked in length about the multi-view design for connectors. I'm not going to talk about that today because for FullDenture it's kind of not really that sensible, but you have those advanced placement options here, giving you the below gingiva design level and behind the proximal contact values. And you see for our automatic placement of our connectors, for a FullDenture, we have a different idea where those connectors should be placed. Obviously, for a bridge, you want to place the connectors kind of in the proximal contact point, so they're not really visible, and you have free space on the papillas and so on. For FullDentures, it's kind of different because obviously you have the acrylic base over the whole jaw. You want your connectors to be placed in a way that they can be hidden inside of your gingiva and are not visible once you place the whole tooth arch in there. And the most important piece here is that the whole tooth arch is kind of connected and stable. You don't really want to place them in your proximal contact points because in the end, you want these areas to look like there is no connector there. There's no material in there. You're going to separate them later on anyway. So placing the connectors a little bit lower makes more sense for FullDentures in our experience. Obviously, you can place them wherever you want. You see, you can actually place them outside of the base as well. That's also something some people prefer, to have them here going on the outside and then just rework them later on. And those values we selected here for like below the gingiva design level or behind the proximal contact points are a little bit higher than for bridges, as you see, because below gingiva design level at 4 millimeters is very low. So they're placed, very low here inside of your gingiva design. So I'm just going to go next again. You can actually, many people want to do that. You can actually also use the direct contact point connectors that just apply a connector wherever the anatomic shapes touch. This also works, but in many cases, if you just print it, it ends in the tooth arch breaking apart in unwanted places. So we prefer to not use that. If you're going to mill the whole tooth arch, on the other hand, this works perfectly fine because the milling tool compensation and everything will just leave some connectors that are really like sturdy in the end. But these are just experiences that you might have to make yourself if you're trying out your whole production method. So then we can freeform our whole denture base. As always, you can obviously go on and create a nice looking gingiva out of all of that. You can kind of draw in all of your root canals and so on. I'm not going to spend too much time on that here today because we're not here to look at freeform features that are not new. But as you see, you can as always do with your base whatever you want, and you see the thickness here as well in this coloration. You can see here down here the yellow color means it's about 2 millimeters thick, so you don't have to get scared just because you see a little bit of this coloration here. Just look at what the value actually means and you're good to go. So then we can adapt everything to the denture base. I'm just going to hit apply right away. Since we have here one whole tooth arch, like a bridge, the whole tooth pockets are not just the pockets for the teeth, but also for the connectors, and everything needs to be in one insertion axis as well. So you're actually able to enter this whole tooth arch into your gingiva base later on. That's why the calculation here is a little bit more complicated for the software, obviously. And it's going to free up, as you see, it's not only going to free up here the teeth, but also for the connectors and so on. We try to place the connectors on the palatal area more or less. So if based on the insertion axis of all of those teeth, you have the software has to cut away the gingiva in areas like this. It's only here in the palatal or lingual area and not here on the vestibular one, because there you want to have your aesthetics. So you might see what happens here. You see the connectors are now getting adapted as well. And now they actually are. And if I hide the anatomic shapes, you see everything here is adapted. It's all one insertion axis. Since the tooth library I selected here has a very short base, there's not much to be cut away. The gingiva was very low. But obviously, if you have, if you place your teeth very deep inside of your gingiva, based on the insertion axis, the software might cut away parts of the gingiva back here as well to give you the option to stick everything together in the end. So then I'm going next again. There's one more thing I need to show you. Obviously, now everything now gets merged and you get your finished denture base and your finished tooth arch. But now if we go to the freeform restorations, I mean, you know that you can freeform your merged restorations. The software actually asks me if I want to freeform my teeth or my base. And if I want to freeform the adapted denture base, there's a really nice thing going on here. As you can see, I can just, as always, go here and add, remove material and so on. Kind of remove the whole design I already did. What you will see is I can obviously not freeform here inside those tooth pockets because they obviously need to stay the same shape, or else I'm not going to be able to, they're not going to fit in the end. Also, obviously, I cannot freeform here the bottom of my tooth base, my denture base. But here there's the keep bottom and boundary fixed check mark. And if I unselect that, I actually can freeform this area here. This is obviously a bad idea to just freeform here inside the palatal area where the space is supposed to be fit. But what you can do is remove this edge here that always gets created on the margin line because you have different directions on your model and your your denture base insertion axis. And you can just, as you see, you can just freeform that, remove that before you even producing your denture base. And so there's also something you normally in most cases have to do in the end. If you manually create your full dentures, you have to remove this small edge here. But here you can do it in the software right away and you're good to go. And after producing that, you don't have to do this work anymore. I think that's pretty neat to be able to do that. So then I'm going next, everything gets saved. And that's it for the new features. Obviously, I want to save the modification. That's it for the new features for our full dentures. Is there any questions regarding that at the moment?
No, not at the moment.
Okay, great. Okay, then we can switch over to our partial framework module. So here we're going to load a case, kind of simple. We have here two reduced pontics, the rest is partial denture teeth. In this case, we have some milled linguals here and attachments on the teeth. It's the kind of case we've shown a few times already. I'm just switching directly to the partial framework software here. I'm not going to the tooth setup again. But as a reminder, you can obviously set up your teeth like pontics and partial denture teeth in the DentalCAD, which already happened here in this case, and can pre-reduce pontics if you want to, which also happened here. And we're going to use the new version of the PartialCAD. You see it's version 3.0. At first glance, there's not many changes in the software. It still kind of works the same, but there's a few extra tools that are available in Expert Mode here. It kind of have like really interesting applications. But you see here, this is our case. We have here attachments. We have some pontics with reduced vestibular areas and our partial teeth setup. And the first thing you might realize, there's one new option here. We can select our insertion axis, obviously. I'm going to select set from view. Since we don't have any clasps, I'm not going to create a draft angle and so on, but here's an option called reduce scan. In this case, it's not really necessary to use that, but if I activate that, you see there's a plane and I can actually move that up and down here. And you see, often you have scans where the model is like super long. Maybe there's parts of the articulation on there as well, or the model itself is just very big. And obviously, then the software has to calculate a refractory for the whole model, no matter how big the model is. This might take more time than you want to, or this might create a bigger data than you want to. So you can actually now reduce the scan, and the whole refractory model will only go to this plane here. So if I'm going to apply this, the software is just not going to use the parts underneath this plane. It's very simple to use, but I think it makes perfect sense to use that if you want to save on your data size or calculation times. You see, now our survey model is just a little bit shorter than before. Okay, and I'm going next. Now I can, as always, edit the block out of the model. Since I'm not going to use clasps, but we have attachments here, there's not really a reason to do that, but as always, you can. You have here in your show height, you can also hide the imported parts. And what many people really like to do is you have here your smooth and smudge tools. Obviously, with the smudge, I mean, most of you might already know that if I just go over the blockout wax, you can just remove that. But also, if I hold down the shift button while going with the smudge tool, you can actually add blockout wax here. So if there's any hard edges where you say, yeah, I don't want this, the metal of the partial framework to go in these hard edges here, you can just add material here. Alternatively, you can just go to the smooth, and here you also have your normal add and remove options to just kind of add material here. It's the normal smooth tool you all already know. So then I'm going next again. And now I can draw my connector and mesh. On this case here, you see there's already some drawings, but if I show my imported parts, I see, okay, the drawings might not fit what I set up in the software anymore, so I can just do whatever I want. I'm going to add my retention mesh here. Not going to pay too much attention to the whole shape. So just like this, and then I can add my base plate. I'm just going to follow this drawing on the model here roughly. As always, there's different ideas how a partial framework should look, but I mean, it's a tool demonstration. And if you're maybe not happy with one of the designs, so you misclicked, or you realize that it created something that's not what you want, you can, as always, go to Edit Curve and then click on whatever curve you want and change everything again. That's pretty neat, I think. The software is automatically going to recognize the difference between the retention meshes here and my major connector. So there's no real, that's going to happen automatically. So I don't have to keep an order in mind to create those or something like that. So, and if I'm happy with the curves, I'm just going next again. And now this whole process gets applied. And you see for my retention meshes, I can set up the retention, the shape of the meshes however I want. I can change the shape and size. This is also nothing new here, so I'm not going to spend too much time here. In your settings, you also can change, obviously, in this case, the values of your major connector. This is a difference between using a major connector and a sublingual bar. A sublingual bar has its own dedicated step, while the major connector is part of the mesh step. So you see here, there's settings for both of them. For the connector, I can actually select between different stipple patterns. You have here your values. Something that many people ask is, why is there an offset in here? The offset for the major connector is not really an offset in the sense of there's a gap between a major connector and the palatal area. It's more like if you would manually create a major connector, most people create that by applying a flat plane of wax, just like maybe 0.3 millimeters, and then an additional plate of wax which has the stippling on top. You're not going to just use the stipple pattern wax because this might be too thin. And here, since the software creates the stipple pattern based on the thickness of the wax plate, if you would just going to use one value for that, it might happen that you could create like a 1 millimeter thick plate, but the stippling would be so deep that there's like break-off points in there. So the offset is just the flat wax that you apply first, and then the thickness is the additional stippled wax that you add on top. So you can kind of control how deep the stipple pattern actually goes in here. You also have a fall off here for your major connector. So in the end, obviously it's going to kind of get smoother towards the edges. You can actually select here a linear fall off, which is kind of, I think, a pretty nice thing to do. So you have 1 millimeter area in the end that's like a very linear, smooth edge all around your major connector shape. So it's going to calculate all of those shapes here. So, and we're done, and you can actually really see here, there's this 1 millimeter straight edge all around it. So then I'm going next. Now I have the step for the draw clasps, which in this case I'm not going to use. So I'm just going to go next again. And you see the software actually asks me if I'm sure about that. And yeah, I want to skip this step. And then I have my fill in wax clone tool, which is kind of like adding a set thickness of material in an area. You see I can draw everywhere on the model, and it just adds the set specific thickness here, in this case of 0.7 millimeters. There's something new here, which in this case is not really perfect to show, but I think it will be quite clear once I show the option what you could use that for, because obviously for partial frameworks, there's lots of people with their own ideas how a partial framework should be designed, and also how the workflow for a partial framework should work. And there is people who, for instance, don't like that you have to create those mesh patterns here based on a curve. Many people here say, I want to draw them myself. I want to create a plate and just cut holes in it or something like that. And we obviously want to give everyone the option to create whatever they like. So if you want to start off with the partial framework in a completely different way, you can go to the fill in wax tool right away and go here to settings. And you see here in settings, there's advanced, there's something called the block out mode. And if I activate that, it's very simple actually. Just has to calculate for a few seconds. You see the whole wax just gets hidden and I only see my block out wax. And now if I draw with my clone tool, you see I'm applying just block out wax. And I could use this to draw all of my mesh risers, different block outs, a different kind of, if I want to have my own dynamic relief, if I want to really control what the block out underneath my partial framework looks like, I can use here the clone tool to create whatever I want. Just going to undo that again. And also there's something pretty neat here. You have here apply offset to entire volume. That's a little bit more, not complicated, but a little bit more unusual to use. Doesn't matter if you have the blockout mode activated or not, but if you do that, you can theoretically apply wax over your whole model, your whole design. You can, on one hand, if the blockout mode is deactivated, just add an offset of wax over your whole model. You can actually click just apply offset and it would be applied over the whole model, or you can again just use a bottom cutoff so it would only be applied up to this plane here. And you can do the same in the blockout mode as well. So you can theoretically block out a whole model with one set value, which is more of a sensible thing to do if you create your own partial frameworks, have your experience with your production methods, and you already know, hey, the fit is always a little bit too tight after printing it. You can actually just add a small block out, one linear block out of like 0.01 millimeter or whatever you want over the whole model before starting your design. So you know there's a little bit more spacer in between everything and it has a looser fit. Or if you're going to create one of those upper jaw full denture metal plates where you just have the palatal area with a plate and then some retentions there, and you kind of want to have a distance there as well because you're going to apply a retention net underneath it manually afterwards, then you can also just apply a blockout over the whole model before you even start designing. It's, I think, pretty neat to be able to do that. I'm not going to show that because it doesn't make any sense at all to use in this case here. but I think it's a pretty intuitive tool. If there's any questions about it, if the explanation wasn't thorough enough, you can go over it again, no problem. So just have to deactivate the blockout mode so I can see my partial again. So then I can just go next again. Now we can draw our finish lines. I'm going to use classic finish lines here. I'm not going to use any fancy tricks. I'm just drawing them here right on our wax. This. There's no new features in this step, so there's not much to talk about. Obviously, as a reminder, if I go to the step where I can apply my finish lines, you have different profiles that you can select from. So here you have whatever you want to create, and you can also, as always, create your own finish line profile in this editor here. Because obviously for finish lines as well, every technician has their own ideas what a perfect finish line in a partial framework should actually look like. And you can see, you can always edit everything here as well. You can change the angulation individually. My placement wasn't really that nice, but it's not really important at the moment. Also, as a reminder, you have also some settings for your finish lines here, and you can taper the ends of the finish lines. As you can see, you can make one end a little bit thinner. In this case, again, doesn't make any sense, but if you have finish lines that go up on an adjacent tooth, it might make sense to have them kind of taper out to the end. Okay, so I'm going to apply those, and I'm just going to go next. There's more interesting things to talk about in this version. Now we are in the add part step. You see we have our pontics here, and the pontics have a little bit of a different color than our partial denture teeth. That's because they have a different selection here for your add part. So if I select one of the partial pontics, they're just here as a reference, meaning I can see them, but there's nothing happening with those. It's just for me to know, okay, this is where my acrylic teeth will be placed later on. So if I'm going to add retention posts or whatever, I know where to put those, or the retention meshes themselves. The pontics, on the other hand, automatically get a non-editable option selected, meaning in the end, when the whole partial framework gets merged, these parts will just be added to the partial framework as is, with no difference in the STL file. A short technical explanation, since the software is not based on STLs, but on, I'm blanking on the word, on voxels, meaning like cubic pixels, like just cubes stacked on top. It's a different type of surface generation. So if I wanted to import STLs and wanted to change them here in the software would have to change those STLs to voxels, meaning the surface information might be lost. If you just want to add a pontic as is without changing anything, it makes sense to have them as non-editable. So the software never transfers them into voxels, but just keeps them as STLs. And in the end, when the whole partial gets converted to an STL, the other STLs just get added. I'm going to add one of those as editable and one of those as non-editable. You see, as soon as I click editable, the color here changes to green, showing me this is going to be changed to green wax as well. You also have here refractory and remove from wax. It's a little bit new that you can just directly see this here. The refractory option was always already part of the import or add parts step, but only in the expert mode. There you can add things to your refractory. You can import crown bottoms, for instance, or bars, and add them to the refractory so you can design your whole partial denture over that piece. So actually, if you created a bar in the past and then switched to the partial denture software, it automatically added the bar to your refractory for you. You also have the remove from wax option, which would just mean you could add a part here that would then be cut out of your partial denture wax. If you have any ideas what to do with that, that's pretty cool for different types of attachments, if you have a specific shape of attachment, for instance. Also, you will see here, you always have the add file option. The add file option gives you the option to add all types of 3D objects, STLs, OFF, OBGs, and so on. What you cannot do in the partial is place them. You can just add them. So you have to place them in the DentalCAD, position them correctly, and then import them here, and they will be added to your partial framework. but you can also add them to your refractory, obviously. Something that's pretty new, you might already see that here, the construction info is shown. I can now import construction infos as well. I can also add SDFA files, which is the file format of our attachments in the DentalCAD software. What that means is, why would I want to import the construction info? If in the DentalCAD you add attachments to your pieces, you can actually import the construction info and it will automatically load the files of those attachments into your partial framework design and can be added to the refractory or can be cut away from your partial framework. Especially if you're creating a type of partial where you have crowns on the teeth of your patient and you directly design them, and then you can add, if you have like a plastic piece or an acrylic piece in between your metal crowns and your metal partial framework, there's often like things to keep a spacer or to give a tighter fit. I mean, those attachments here are technically with an acrylic piece around it, but we rescanned it. But if you're not going to do that, you can add this attachment to your crowns in the DentalCAD design so that the DentalCAD design still is the same original primary piece of your attachment. Then you have your plastic piece around it just as a placeholder. And then here in the partial framework, you can import this and can design around this additional spacer as well. You can have them, those pieces to be cut out from both like your crown and your partial at the same time and have a spacer, a room for whatever you want to put in there as well. So there's lots of new options here if you want to work with attachments. I think it's really neat to have these options. Okay, so I'm just going next. You will see this tooth will be converted into green wax. Now the other tooth will stay as it is. Now I have my added wax tools. I can, as always, smooth, add wax, whatever I want to do. In this case here, I'm just going to smooth the finish line here a little bit. You might already realize, hey, there's still parts missing here. I'm going to take care of that later on. And you see for the tooth that got converted into green wax, here I can add material. I can, you see, edit all of this area here. I mean, I can obviously also edit this here. But here for the other tooth that is not converted to wax, it just stays in the blue color and I cannot even click on it. It's not editable for me. I think that's pretty intuitive. And now if I go next, I'm in the build step. I can calculate the whole partial framework and convert it to an STL file. But I'm going to switch to the expert mode. There's still some things that I can do. Obviously, I can here create my milled linguals. For that, I prefer to just draw curves, actually. You can do that before. You can, as always, switch to the expert mode whenever you want. There's no reason to wait until the end of your design to do that. In this case, might have been smarter to do that beforehand. Oh, didn't really pay attention how to draw. Okay, that looks a little bit better. And you see, I can just draw some curves here. If I have green wax available, I can draw on the green wax, or I can draw underneath my imported parts here as well. Obviously, if I'm going to draw a shape that complicated like that, I really have to pay attention because the software in most cases might not really be able to understand where to go on with the. I think I'm misclicked. I'll accidentally draw two different curves, and that's also what I have to pay attention to, not to double click all of the time. I'm sorry. So you see, I can draw very complicated shapes here, but I obviously, as always, have to kind of pay attention what I'm doing. If the curve is actually connected, because in a case like this, the software has no idea of what I'm doing now, because this is kind of more like a neat usage of those features here. I can see I cannot really enter in my steps based on the webinar software. So I'm switching to the major connector step here. And you see the software automatically selects one of the curves, the biggest curve, thinking this might be my major connector. And here in my settings, I can actually now select maybe a smooth pattern. So this whole thing will be smooth, and I can change it to be in a set thickness like 0.5 or whatever. I mean, I can always combine those. And if I now click on apply, it will just add material here. you see, and it automatically selects the other curve now, because now this is the only curve that has not been used yet. And I'm still in the major connector step. So software kind of assumes this will be my major connector. And we have here our milled linguals. And again, I can just go in there and now edit those and kind of, I mean, obviously for areas like this, I might need to add wax here because it doesn't really look that nice. Yeah, but I think it's pretty simple. We already have videos of cases like this in our on our YouTube channel and so on. So there's different workflows you can go on here, how to create a case like this. But I can, as you see, always just edit everything. I could also now go to the clone tool and add material here if I wanted to. See, just like this. Okay, this doesn't look that nice, but I think you get the gist of it. But there's also some things that are new. I kind of have to see if I can remove my webinar panel here. Okay, great. There's also other new things here in the expert mode that you might want to know about. If I now go to my prepare for build step, you see here we have here our values for tolerance. So how close will the STL actually fit the created voxels? So we can set up a tolerance so that the STL file size is a little bit smaller and so on. But you also can go here to your settings, and you see there's lots of new selections here. A very important thing about that is I'm in the expert mode right now. If I click on wizard, I'm also in the build step, and you see one of the buttons just got hidden. And if I go to the settings, it's less than that. We specifically hid some things in the expert mode, so new users will not be confused by too many different settings. You can actually, if you don't know what you're doing with those settings, obviously create something that will not work in the end, as always. So we kind of try to hide something in the expert mode. Here's the apply relief button. And here in the settings, we have also all of the values for your relief. The first thing we're going to show you is if you click on apply relief now, you have here your dynamic and static relief. Those are just different values for all of the different areas of your partial framework to be added, so the whole partial can actually fit on your refractory model in the end. Obviously, for a big plate like this, if you have hard edges on your plaster model, the software tries to create something like a relief that intuitively follows the shape of the plaster model. So if there's hard edges, it blocks them out more than just a flat surface. So it's not just one value stuck on top of it, but more like, yeah, it's dynamic. There's different values for your like connectors and imported parts and so on. Obviously, you don't want any spacer underneath your clasps normally, but you can add this here and so on. As you see, this is a complicated topic. So talk to your reseller or your provider of the software, have them explain all of those different pieces. But now I just clicked on the apply relief button, and you see there was nothing really happening here. But if I now switch to the edit blockout step, for instance, where I can see my blockout wax, you can see that the dynamic relief actually got applied before even converging the whole partial framework. The relief will be applied anyway, no matter if I click the apply relief button or not. But the difference here is that I can actually now see the relief and can technically edit it. And you can see the dynamic relief here blocking out with different strength in different areas. Also, I see if I can say the major connector curve. Yeah, you can see the major connector curve here. This is the shape of our major connector, not to be confused with the drawing on the model. And you can see there's like 1 millimeter area that was set up in the settings where there's no relief applied. So obviously this 1 millimeter edge of your major connector will just perfectly fit no matter what. And you can now actually go here and you see add blockout wax to your relief or remove your dynamic relief. Just as a reminder, this is really an expert function. So if you're not sure about your dynamic relief, just don't touch it. If you have any experiences with the creation of your partial frameworks with your production method, obviously you can go in there and change whatever you want to see if you get a better outcome in the end.
Friedemann?
Yeah.
I would like to remind you that we have 3 minutes left in our schedule.
And I'm already nearly done. There's one thing I need to talk about in the settings. You see here we have non-editable part merge optimization in the settings as well. I think also only in expert mode. Yes. You see in the expert mode, you can select that. You have non-editable part merge optimization, meaning if you have non-editable parts like this, how will the partial framework be merged in the end? You have here milling, no resurfacing fast, watertight, resurfacing fast, and watertight, no resurfacing slow. Meaning, if you're going to mill the whole piece, like if you have, it's more interesting if you have crowns added to your partial framework. And if you're going to mill the whole crown, it will just stick the crown in the end to your partial framework, and there might be intersections. There might be, and normally there's no intersections there and so on, but there might be an edge between the crown and your partial framework, because obviously you cannot edit here this edge between the two pieces because one of the pieces is not touchable by you. It's not editable. If you're going to mill everything, doesn't matter. It's going to work fine. If you're going to print everything, maybe these edges are more important to you than the surface of your crown, then you can select watertight resurfacing, meaning that the software will recalculate the surface of the crown anyway. And then you can print everything, and maybe the crown bottom isn't as important to you as for like a milled crown, then this also works very well. If you're going to create a partial framework with crowns that need to fit perfectly, but also want the edge to be smooth, then you can select the last option. This is a very complicated calculation. That's why it specifically says slow. It might take longer. It might, it might not create a bigger file. I accidentally just said it, but it's not true. It just might take longer. That's why we put here slow. If you're going to create a partial specifically for that, you have an option here now, just so you know. It's, I think, very interesting. But for now, I think we're done with the partial frameworks finally. So I can click Save for Build, and everything will be calculated in the end. If there's any questions coming in the next few minutes, that's also okay. If not, I want to thank Joe and Pina for the support, and thank all of you for participating.
Thank you for the show.
Okay.
All right. I would say we're done.
That's great then. We'll see you all in the next week for Exoplan as a webinar. Okay, great. Then have a great day.
Bye.